Yep. Let's start off, everyone. Switch on your cams. Great. So this was the last thing that we did. Average velocity, instantaneous velocity. Great. So before going ahead, let's do one more problem and then we'll go ahead. So we have a wheel here. The wheel rolls on a floor. Without slipping. We have done this in vectors, if you remember. A is the bottommost point. R is the radius. So when this wheel rolls forward a bit, the point A comes somewhere here. Find the distance traveled by point A when the wheel rotates by an angle theta. You guys remember how this path will look like? So, yeah, cycloid, last time we discussed this. So it's a wheel of radius r. There, this was the path. If you remember, this exact same question we did in a vector. So this is how the point A will go. So what I'm asking you to is, if this is your point A, so a part of it, when this thing has rotated by an angle theta, I want you to find this length. So somewhere here. I want you to find this length here. And I hope you remember this. In one complete revolution, the center of the wheel will travel a distance of 2 pi r. That we knew. Now I'm asking you to find the length of this red line. And this would be a cycloid. How do we do this? You guys need to refer to the notes. Let's start like this. Can you find the coordinates of A? Start from there. That we have done before already. Start from there. Find the coordinates of point A. If the initial point A was origin, find the coordinates of point A. If you guys are not revising your notes and if you're not remembering the previous stuff, you will have a problem. As we go ahead, the chapters will start becoming more and more tough. You'll be lost.
So may I try?
Can you switch on your camera, Anushka?
Sure, sir. 1 second.
Yeah, Anushka, you can try. And you can, if you got an answer, you can type in the chat box. You want others also to try.
Okay.
Yes, you can send your answer to the co-host. Find the distance traveled by that point A when the wheel rotates by an angle theta. No, Anushka, I think you're getting confused. I didn't ask you arc length. You're finding this distance. We don't want that. When the wheel rotates, this is how the path will go. The wheel won't be at the same place, isn't it? The wheel also would have moved forward. You got the coordinates, no? Yeah. Coordinates we have done in vectors, people. You all forgot. There, exact same thing. I asked you to find the vectors, coordinates of A as function of theta. These were the coordinates, if you remember, r theta, comma r sine theta, and r minus r cos theta. Let's see. First thing, the first concept is, you should definitely refer this. This is the first concept you need to know. Whenever a wheel rotates, right, the center of the wheel will, if you complete one revolution on the floor, the center of the wheel will travel a distance of 2 pi r. Is this clear? So when you roll a wheel on a floor in one revolution, the center of the wheel will travel 2 pi r. And then look at the coordinates what we did. If the wheel rotates by theta, then the center of the wheel will travel a distance of r theta. Isn't it? For 2 pi angle, you will travel 2 pi r. For theta angle, you will travel r theta. So when this wheel rotates by r theta, so if I take this point as your origin, and when this thing has gone theta here, so on this floor here, this must have traveled r theta. So this point coordinates will become r theta, comma 0. And I'm asking you to find the coordinates of this point A. And how do we find that? Drop a perpendicular. That would be a right angle triangle. This length would be the adjacent side, which is r cos theta. This would be the opposite side, which is r sin theta. And you can see the coordinates of A here. What will be the coordinates of A? This is r theta. This is r sin theta. If you subtract them, you will get the x coordinate will be r theta minus r sin theta. And the y coordinate will be this distance here. This will be the full radius r minus r cos theta. That will be your y coordinate. Is that making sense, everyone? And we have done this in vectors. I'll refer it here. Page 73, vectors. You should definitely refer this in case you forgot. Same thing, I explained you in much more detail there. Arya, can you keep your cam on? Is this clear, everyone? How did you get the coordinates? The center, this thing has traveled r theta, and this distance is r sine theta. So what is the difference? R theta minus r sine theta. That's your x coordinate, isn't it? That would be your x coordinate. And the y coordinate would be, this is r cos theta, and the full thing is radius r. So r minus r cos theta is the y coordinate. We got the coordinates. So what? Now, once we got the coordinates, x is equal to r theta minus r sine theta, and y is equal to r minus r cos theta. Do you guys remember any formula for distance? If you know x and y, is there any formula for distance in terms of x and y?
X square plus y square, sorry.
There, this one, remember? We have two formulas for distance. If the velocity is given in terms of time, use integral mod v dt. If the positions are given in terms of x and y, then for the distance formula, I can use this guy. Dx into root over 1 plus dy by dx whole square. I know y, I know x. Can you do dy by dx? And then substitute here and then integrate. This is the formula for distance, everyone. I hope you remembered, which we have written last time. You can note it down in case you forgot or if you don't know. So distance, we have two formulas, one in terms of time and one in terms of positions. So if x and y are given, the trajectory is given, you use this formula, 1 plus dy by dx whole square. Copied the formula? Anushka, know the formula? You know this?
Sir,
You can just copy it down. Yeah. You can refer the notes later on. Yeah. We have done this last class only. So others there, you know the distance formula. So I know x coordinate, I know y coordinate, I know the formula. Now, can you solve? I'll give you 2-3 minutes. There. This is your x coordinate, this is your y coordinate, but everything is in terms of theta. Understand, you're not finding the displacement, you're finding the distance. This point A won't go in a straight line. This guy will be actually going in a curve like this. We are trying to find the length of that curve. That's the distance. In case you forgot how we derived it, let me just show you that also. If you have a curve like this and you're trying to find the distance, so let's take it as ds. So this can be treated as dx and dy. So this small arc, if I just magnify this, it looks like a straight line. So ds is so small, you can treat it like a straight line. Ds is a small part of a curve. I can use my Pythagoras theorem here. So ds will be root over dx whole square plus dy square. So this is how I got the formula actually. If you just take out dx common, you'll get that formula. If you want distance, we have to integrate this. Will be integral ds. This is integral root over dx whole square plus dy whole square. Now in our question, x is given how much? R theta minus r sine theta. Y is given r minus r cos theta. Differentiate both sides with dx by d theta. This will be r minus r cos theta. Dy by d theta will be 0 minus plus r sine theta. Cos का differential is minus sine theta. So we get dx is equal to r into 1 minus cos theta d theta. Dy is r sine theta d theta. Now take that and put it in that formula. So we get distance will be integral root over r square 1 minus cos theta ka square plus r square sine square theta. That d theta comes out of the integral. And the limits will go from 0 to theta. Because you said find the distance traveled when the wheel rotates by theta. Now can you integrate that? That looks dangerous, but if you expand that, you get a pretty neat integration. Try. I have finished everything for you. You just need to solve that integration and you're done. Any answers?
The solving.
Mm-hmm. Everyone should try. Everyone should try. It is just an integration. 2r theta plus sine theta. You got that. Did you take it out of the root, Ray? How did you get it out of the root? There is a root sitting on the top. You ignored the root completely. If you expand this, r comes out of the integral. It will be root over 1 minus cos theta is 1 minus 2 cos theta plus cos square theta plus sine square theta. This will be r into integral root over sine square theta plus cos theta becomes 1, 2 into 1 minus cos theta. You don't know how to integrate this, but we know 1 minus cos 2 theta is 2 sine square theta. Remember this from trigonometry? Put 2 theta is equal to theta. Then this becomes 1 minus cos theta is equal to 2 sine square theta by 2. This is already the third time you're seeing this. And this thing I told you in trigonometry, this is the most important one, keeps popping up everywhere. Now if you substitute here, now this root will go off, you'll get 2 into 2 sine square theta by 2. Root d theta. This simply becomes r into 2 comes out integral sine theta by 2 d theta. And this you know how to integrate. This will be 2r. The integral will be minus 1 by minus 2 cos theta by 2. Limits will go from 0 to theta. This would be minus 4r. If you put the limits, this will be cos theta by 2 minus 1. You can write this again 1 minus cos theta by 2 as 4r into 2 sine square theta by 4. You will get 8r sine square theta by 4. That's your distance traveled.
So can you show the last slide, please?
Come again.
So can you show the last slide, please?
This one.
Yes, sir. Sir, but it was supposed to be dy by dx whole square plus 1 ka root, right?
वही है ना, if you take out dx common तो वही आएगा.
So then what will happen to that dx?
अरे God, it is the same thing, right? Send that dx back inside, na? You'll get dx square plus dy square.
Sir, I didn't get that.
What you didn't get?
Sir, like वो extra dx का क्या होगा?
Where is extra dx? This and this are same.
Okay, sir.
If
So
you take out dx common, यही आएगा ना?
yeah, sir, but in that second equation which you have written,
But this
integral
is
of
dy by
ds.
dx, na? Right, God. So divide, na? dy by dx divide करके substitute करना.
Sir, no, but what we are like integrating in respect to in the second line.
When you do that, you'll get a d theta left over. You're integrating with theta.
Sir, in the second line.
Where? Which second line? This one.
Yes, sir.
There is a dx and dy, right? It is not a complete form. It will come out.
Okay,
X
okay.
and y are still variables. So once you have opened up completely, then you will see, na? देखो d theta आया ना end में.
Okay.
That
Then
is
we
not a
use
complete
distance
form.
formula there.
Yeah. Did everyone agree with this? This and this are same? I just took out the dx outside. I did nothing new there. Is this clear, everyone? See, once I got till here, it is over. It is after this, it's all max. So what we found out here is this. If you have a wheel and when it rotates, And let's say this is point A and the A goes somewhere here. And then let's say in this process, it has rotated an angle theta. So this A will be going something of this sort. It will be going in a curve. So you found out this distance is 8r sine square theta by 4. And if you take theta is equal to 2 pi, that means it has done one full revolution. Then the path would look something like this. That's what you get a cycloid. This point A here would be going like this. It's like jumping like a frog. This total distance would be, substitute theta is equal to 2 pi, you will get 8r. So examine, this would be the question. If a wheel completes one full revolution, find the displacement of point A, find the distance traveled by point A. This will be the displacement, which is the distance between initial and the final point. Displacement will be 2 pi r, whereas the distance traveled will be 8r. Because x is depending on theta. And you differentiate with whatever quantity it is depending, right? X is depending on theta, so you differentiate with theta. And the question it is asked also find the distance traveled when it rotates by theta. Everything is being asked in theta, so right, Arya?
Okay, sir.
Is this clear, everyone? So I can even ask you like this, find the distance traveled when it rotates 60 degrees, when it rotates 120 degrees, 150 degrees. So there we got a more generalized formula in terms of theta by 4. So this thing which looks like this circle, the cycloid, the path which I showed you here. So this total length will be 8r. That is a direct question, I think, in mains or bit somewhere I saw the question. They simply asked find the distance traveled in one revolution, and everyone wrote 2 pi r and came. It is 8r. So it's a good result to remember. Examine you, it's a little long to derive, it takes time. Any doubts on this? Clear? Next one. Average acceleration. So average acceleration is simply the change in velocity by time. Delta v bar by delta t, which is v final minus v initial by time. Now, if you make the time very, very small, this will become instantaneous acceleration. We did the same thing with velocity, if you remember. When you make the time intervals very small, averages become instantaneous. So instantaneous acceleration is limit. When the time tends to 0, this will become delta v by delta t. This is what becomes dv by dt. This is the definition of a differential dv by dt. So if someone simply says acceleration is dv by dt, they're talking about instantaneous acceleration. If it is average, they will mention it to you that the average acceleration is what? A is equal to dv by dt. There is another form of writing this. If you remember, we have done this in calculus. I can write this thing as dv by dt into dr by dr. I told you I'll give you a proper form for this. V dv by dr. Basically, this dr by dt becomes velocity. So the proper way of writing this thing is acceleration is vx dvx by dx. So the velocity in the x direction differentiated by the x coordinate into y cap plus vy dvy by dy j cap vz dvz by dz. So this thing, each component gives you acceleration in ax, ay, and az k cap. This is the acceleration in the x direction. This is the acceleration in y direction. This is the acceleration in z direction. That would be a proper form of writing acceleration in terms of v dv by dr. So we have two forms for acceleration. dv by dt, use it if time is given, use v dv by dr if position is given. And your average acceleration is v final minus v initial by time. You can note it down in case you don't know this thing. You can put on the main points, but yeah, you will get the PDF anyways. So focus on solving and understanding the stuff. Copy it, everyone. Great. Let's say a question. Let's do something a little easier. So we have a particle going in a circle. This is your x-axis. This is y-axis. Radius is r. So we have a particle starting from origin going with speed u. So this is your t is equal to 0. With constant speed u. Find the average velocity. Find change in velocity. Find average acceleration. Find instantaneous acceleration. After time t. 4 questions, everyone. So this guy is going in a circle. So after time t, it will be somewhere here. So at that point, find the average velocity. At that point, find the change in velocity. At that point, find average acceleration. And at that point, find the acceleration. So average, change in velocity, average acceleration, instantaneous acceleration. And remember the definitions. What is average velocity? What is average velocity? Displacement by time. What is change in velocity? V final minus V initial. What is average acceleration? V final minus V initial by time. What is instantaneous acceleration? dv by dt. There you can see vectors, calculus, kinematics, everything keeps coming together. Let's give it a try. Arya, are you there?
Yes, sir.
Look at the question. We have a particle going in a circle with speed u at t0. Find the average velocity, change in velocity, average acceleration, and instantaneous acceleration after time t. 4 questions. Don't worry about everything. Start with first one, average velocity. Let's start from there. I'll give you a minute, 2 minutes for that. Then I'll show you one. Find average velocity. The definition, displacement by time. Or UT by right, Aditi. Hey, Shreyansh, you forgot something. Let me help you with the first one. Again, what is the definition? Average velocity, displacement by time. What is displacement? Change in position. So after time t, your particle from here must have gone somewhere here. Let this angle be theta. So this coordinates are r comma 0. This coordinates will be how much? R cos theta and r sin theta. So the coordinates of this point will be r cos theta, comma r sin theta. But how do you find theta? Since this particle is going in a circle with a constant speed, it will travel a distance of speed into time. So this arc length will be speed into time. We have done this before, u into t. Angle theta is defined as arc length by radius. So we got theta is ut by r. Is that understood, everyone? In time t, the particle will travel u into t. So there we got theta. So then you're done. So average velocity is displacement, that is your final position vector minus initial position vector by time. So Shreyansh, you forgot to subtract the initial one. So r final will be r cos theta I cap, r sin theta j cap, minus r I cap by t. Yeah, you can leave it like this. You're done. So r into cos theta minus 1 I cap. They ask you from
R J cap.
it's a vector, right? This is a position vector. What you're saying is velocity vector
Oh yeah.
by time. That you can leave it like this. They ask you for magnitude, you can find the mod of this, but average velocity is a vector, so I will leave it in vector form. This is what is being asked, the first question. Is this understood, everyone? You guys know, right, how to find r final and r initial. We have done that. So the only thing you have to subtract now. Any doubts on this? What is the second question? Change in velocity. Try. I'll give you a minute for that. If this guy is going in a circle, find the change in velocity. This question we have done in vectors. Do you remember? There is a standard formula I told you to remember. Magnitude of change in velocity. Anyone remembers? 2b sine theta by 2. याद है? I told you this will keep popping up. It was a standard question in CET mein, that would be like a standard question. They'll directly ask you. Anyways, let's try to find it again. Find the change in velocity. That was the second question. Third question was average acceleration. Fourth question, instantaneous acceleration. Any doubts on this page, please ask me. The change, the average velocity. Clear, na, Vanchika? Clear with this? Siddesh? Clear with this? Let's get the change in velocity. Average acceleration, nahi aa raha. That's not the answer. What you found was instantaneous. What is change in velocity? V final minus V initial. Aditi, you got the magnitude right. Trishi, clear with this? Try. Finish off and get the average acceleration then if you got the velocity. Arya, keep your cam on. Look at this thing, change in velocity. Initially, your particle is here going up. So your initial velocity is uj cap. This is your V initial. After some time t, this is your theta. This guy is going like this with speed u. If that is theta, this angle will be 90 minus theta. You can clearly see V final will be u cos 90 minus theta minus I cap plus u sin 90 minus theta j cap. So this is minus u sin theta I cap plus u cos theta j cap. This is your V final and V initial. You are asking for change in velocity, which is V final minus V initial by this thing, subtract them. So this would be minus u sin theta I cap plus u cos theta minus u j cap. This is your change in velocity. You want average acceleration, actually both are related. What is average acceleration? Change in velocity by time. So whatever you got, just divide by time and you got your average acceleration. U sin theta I cap and u cos theta minus u j cap by time. So since I asked you a vector form, but if you want to find magnitude of delta v bar, this will be 2u sin theta by 2. This we have done in vectors. Where did we do that? Here. This was the proof, page 118. This problem. Like I said, quite an important result. I have seen this coming multiple times in all these other exams like BITS, MIT, Vellore, and all those exams. What is the last thing left out? Find the instantaneous acceleration. What is instantaneous acceleration? dv by dt. V I already know, so just differentiate this guy. If you differentiate velocity, you'll get acceleration. There, I already gave you the velocity. And what is theta? Theta is ut by r. You have all the data points. Let's see. So your velocity v is this guy u sine theta I cap plus u cos theta j cap. And we know theta is ut by r. So substitute there. That will be minus u sine ut by r I cap plus u cos ut by r j cap. Now I'm asking you for instantaneous acceleration, which is dv by dt. So differentiate this. Sine ka differential, cos ut by r. And remember, we had to use chain rule. Then differentiate whatever is inside this function here. That would be u by r. I'll just write it down. I hope you know that. You have done things like this before. This will be u cos ka differential is minus sine ut by r. And one more u by r comes out. So your final function will look like this, minus u square by r cos ut by r I cap plus sine ut by r j cap. Later on in circular motion, we will call this thing centripetal acceleration. This is your acceleration, everyone. You can actually further simplify this. You'll get a is equal to minus u square by r. This is r cap. This also we have done this. So that means when the particle is going on a circle, at any instant, if you see, if this is your r bar, your acceleration is towards the center, a bar, and your velocity is tangential. This is how the three vectors look like. R bar, radially, velocity tangentially, acceleration towards the center. This is also called as centripetal acceleration. Nah, don't worry about it. When it comes in circular motion, I'll show you again in a different way though. But this is the proof for that. This is your instantaneous acceleration when you're going in a circle. All clear with this? And this, where we did? We did this in calculus. Remember this question? Particle goes in a circle with speed u. Find position vector as function of time t, velocity as function of time t, and acceleration as function of time t. We found the position vector, we differentiated twice. We did the same stuff before. And after this, we did something even more deadly, if you remember. 13 differentials. And there we showed you something, the same thing I showed. Every time you differentiate, the vector rotates by 90 degrees. So don't forget. In case you forgot, go back and refer today or tomorrow. Get it clear. Any doubts on this?
Sir, can you again explain the delta V part, change in velocity?
Which part you didn't get? Did you get the final velocity?
No, sir, I couldn't get the V final part.
This is just a vector, right? This is u. This is u cos theta, u sin theta, vector components.
Yes, sir, but why did why did we take U as the velocity?
Particle is going in a circle with constant speed u. How did you do the first part then, right?
Sir,
How did you
first
get this
part I was
angle
getting-
theta? Angle theta, we got theta ut by r. You didn't ask me what is u here.
I actually got the first part, but second part I was
No, no.
confused.
Why बोल रहा हूँ? First part में theta was ut by r ना. You didn't ask me what is u here.
Uh,
Now
I
suddenly you
got
had a problem with
part
u there.
U.
But got it na? U is the speed of the particle.
Yes, sir.
So you're different. They're dividing u into components I cap and j cap. So that's your velocity. Sure. My concern is not that, that what is u here. That means what did you do here? You ignored the u here. That is a problem. Next thing. Okay, too much vectors, too much differentiation. Let's do something little more pleasant. Let's say we have a clock. Standard one. Well, 1, 2, 3, 4, 5, 6, 7. So it's a pretty big one. So we have OA and we have OB. So OA is your R sand. Whose length is 1 meter, big clock. OB is your minute hand, 2 meters. So A and B are tips of the needles. So A and B are the tips, tip of that arrow. Initially, the time is 12 a.m. So 12 o'clock, midnight. Find the average velocity of point A and point B. When the time is 6:40 p.m. Again, what is average velocity by definition? Displacement by time. I just want the magnitude. I don't need a vector. Get me the magnitude. Find mod of average velocity of A and B when the time is 6:40 p.m. So this point A and B, how will they go? Which path will they go? They would go in circles, right? Yeah. Try. You got 3 minutes. Anyone not clear with the question, please ask me. I'll explain the question again. Question is clear? Go ahead. You got 3 minutes. This is something which you see every day, a clock. It's midnight, 12 o'clock. That's your starting point. When the time becomes 6:40 p.m., find the average velocity of A and B. Average velocity definition is straightforward. Displacement of the point by time. I just want the magnitude. I don't want vectors.
Sir, in
Try.
seconds or in minutes?
SI units always it is meters per second. If the numbers are big, fine, you can just leave it like that. When I show you, see whether you got it right. Or if you want to do that, then leave it in meters per hour. That is also okay for me. That is all fine. The calculations are okay. Let's get the concept clear. Think, think, think. 5 root 3 root 2. Okay, first thing, there are few traps here. I don't know how many of you fell into which trap. So let's see the traps. The first trap, how will the clock look like? How will 640 look like? For example, see now the time is 9:20, 9:25. Is that hours handle exactly at 9? That is the first trap. So if someone asks you to draw the clock for 640, this is 6, this is 7, this is 8. The minutes handle will be at 8. There is no problem with that. B will be here. But A will be 640, right? It will be more closer to 7. It will not be at 6. That is the first thing. The picture would look like this. Hope you're getting it. Now we know in 1 hour or in 60 minutes, right? The hour handle will go from number to number in 60 minutes,
30 degrees.
30 degrees. In 60 minutes, the hour's hand rotates 30 degrees. How do you notice 30 degrees? There are 12 numbers and total angle is 360. 360 by 12 is 30 degrees. So you can use unitary method. So in 40 minutes, it rotates 20 degrees. That means this guy is making an angle of 20 degrees from here. This is how the clock will look at 6:40 a.m. p.m. This is the first trap. Most common mistake, people think A is at 6. If you have done that, you're gone. Clear with this? Next thing. And then what did I ask you? I asked you for average velocity. So what is average velocity? Displacement by time. So let's find the displacement first. Let's look at each needle. Initially, B used to be here. Now B is here. So initially B used to be here at 12. Now B is at 8. So the angle between two numbers is 30 degrees. So this angle is 120. I want you to find the distance between them. So this is your displacement. This is 2 meter. This is 2 meter. It is an isosceles triangle. So I can use sine rule. So the triangle would look like this. This is 30. This is 30. This is 120. This is 2 meter. This is 2 meter. Let's take this as x. Sine rule. X by sine 120 is equal to 2 by sine 30. Or you can just drop a perpendicular bisector and do all that stuff. That also works. So we get x is equal to sine 120 is root 3 by 2. Sine 30 is this, 2 root 3 meters. That's your displacement. This is for B. Now, what is the average velocity of B then? So average velocity of B is the displacement by time. This is the second trap. What is the time? It's not 6
12
hours,
hours.
18 hours. It is 6:40 p.m. The needle must have rotated 12 p.m. to 12 a.m. and 12 a.m. to 6:40 p.m. Are you getting it? It was 18 hours and 40 minutes. Time was 6:40 p.m. It's not a.m. So this thing must have gone completely 2 revolutions. Are you getting this? I could have asked you to find the distance traveled also. That also would have been fun. That needle would have made 18 revolutions. So average velocity by B, so this is 2 root 3 and the meters by time will be 18 hours and 40 minutes. Yeah, you can convert that into seconds, but 6:40 p.m. is that. So time would have been 18 hours, 40 minutes. So 18 hours is 18 into 3,600 seconds plus 40 into 60. You can leave that. That is your time in seconds. Any doubts on this? I think the biggest thing is that only. Most people don't realize that is 20 degrees.
Sir,
B will still get it. A is a catch. Re.
sir, can't we use the formula delta V is equals to 2 use sine theta by 2?
That is change in velocity, right? I am asking you what? That you got change in velocity by time, isn't it? This is average velocity, God. That will give you acceleration.
Sorry, sir.
What is average velocity definition? Change in position by time.
Yeah.
Remember that. Exam don't go up. What about the point A then? A used to be here. Now A is somewhere here between 7 and 6. Like this. So this was 20 degrees. That means this angle is 160. Yeah, these numbers are not good. This value actually you can't find. So this will be 10 and this will be 10. Or actually I can do that, isosceles triangle ka bisector thing. I will drop a perpendicular from the center. This angle will become 80 degrees. This is 1 meter. So this will be the opposite side. This will be 1 sine 80. This also will be 1 sine 80. There. The displacement of point A will be 2 times sine 80. You can leave the answer like this. We can't simplify this further. Average velocity will be displacement by time. Clear, everyone? Can you tell me what is the distance traveled by A and B? In this question, can you tell me what is the distance traveled by A and B? Try. I'll give you a minute. Just calculate roughly. What is the distance traveled by A and distance traveled by B when the time is 6:40 p.m. Initially, it is 12 a.m. Try. I'll give you a minute or two. Find the distance traveled by A and B. Again, I am just teaching you circles, circumference, angles, all that stuff. It's like kind of a trigonometry problem, you can say. Find the distance traveled by A and B. Eight pi by 3. Mere God, what are you doing? 28 pi by 6. Why are you guys getting such a small values, right? In 1 hour, how much will the minutes handle travel? One full revolution. In 60 minutes, 1 hour mein, this will travel one full revolution. In 18 hours, 40 minutes, it will rotate 18 and 2/3 of a revolution. Isn't it? B will travel a lot. A will travel less. So in 12 a.m. to 6:40 p.m., this is 18 hours, 40 minutes. That is, B covers 18 plus 2/3 of a revolution. The distance of B will be 18 plus 2 by 3. Yeah, you can simplify that and just leave it into 2 pi radius of B. RB is 2 meters. You can substitute and finish it off. What about A? A covers, A is interesting. See, this A, right, from 12 o'clock to 12 p.m., it will complete one revolution. Then it will complete another. If I see A ka picture, it looks like this. A would complete one revolution, one full circle, and then it will complete one circle like this, where this angle is 200 degrees. Remember, there is a 20 degrees ka piece here. So this A has covered 180 plus 20. So the total angle will be, how much is that? So theta covered will be 360 plus 200. That is 560 degrees into pi by 180. I can convert this into radians. This would be the number of distance traveled will be radius of A into theta of A. Clear with that? So A covers a total angle of 560 degrees. 360 plus 200. Convert that into radians. Radians into radius will give you the distance traveled. So one of the most common mistake is people think it is 6:40 a.m. People think it is 6 hours 40 minutes. So just be careful with that. All clear with this? Take a break. Come back by 9:37. Take a small 5-minute break. Any doubt so far? Anything that you're not clear so far, ask. Or else go, take a break, come back in 5 minutes. Any doubt so far? Okay, come back in 5 minutes. Start off. Let's do one more. So before doing this question, let me explain you this again once more, which we have done last time. Average velocity and instantaneous velocity. What is average velocity? Displacement by time. So what is the direction? The direction of average velocity will be along the displacement. That means if a particle is going like this, and if I ask you when the particle is here, what is the average velocity? This is your average velocity. So you're assuming the particle has gone straight from O to O. But if I ask you what is the instantaneous velocity, that will be tangential at every point. Do you guys remember this? At every instant, your velocity is along the path, whereas the average velocity depends on your point. If I ask you what is the average velocity at B, I will assume you have gone from O to B directly. That's your average velocity. Whereas instantaneous velocity is the tangent at every point. Clear? That was a concept there. So let's see a question on that. So we have a particle which is going something like this. It's going like this. It's going from A to B. So the question is, this is the path of the particle from A to B. How many times average velocity and instantaneous velocity are parallel? That's it. That's the question. This would be a pretty nice mains level question. A particle is going on some random curve like this. It's given this curve A to B. How many times the particle average velocity and the instantaneous velocity are parallel? Others, if you're not keeping your cams on, you'll be removed from the classroom. Two times. Five times. Four times. Yeah, so many answers. Zero times. So finally, what is the answer? We have everything. 0, 2, 4, 5. 1 and 2 are missing. 2 भी हो गया. 3 is missing. 2 बोल दिया. Okay. Someone tell 3 also ना. बस वही बच गया. 1 भी बोल दो. Fill up all the numbers. See. Listen carefully here. This is more of a theoretical question. These are the kind of questions, like there's not much to solve, but you need to think. Again, what is the average velocity का definition? what is instantaneous velocity definition? Let's start from there. Instantaneous velocity is tangential to the path. So the idea here is, from the initial point, can you draw a line which becomes a tangent to the curve? That means, look at this point here. If I draw a tangent to this point here, this will be the delta v bar, agreed? The line joining initial to final is the average velocity. And the tangent to the curve is also the velocity bar. Are they both parallel? So the whole question is, you need to find the points, where from point A you should be able to draw tangents. So from point A, I can draw one more tangent here. I can draw one more tangent here. I can draw one more tangent here. And at these points, when it's a tangent, the velocity is also tangent. I cannot draw a tangent here. No? This will be like this. That is not a tangent. So this is not, has nothing to do with maxima minimus. So there are actually 4 points where I can find their parallel. Did you guys got this? So there are 4 points. 1, 2, 3, and 4. So this is how you do this. So draw tangents from point A. So starting from A, start drawing lines. And whichever lines become tangent to the curve, those are the points where the velocity and average velocity are parallel. At this point, the average velocity and v bar are parallel. So here the number of points is 4. Sure. What about point? That's a zero vector, right? It's an undefined direction. We don't count it. If you are exactly at point A, then the delta v bar is zero vector, isn't it? So we don't count that point. How have you got something?
So, like at the downward curve kind of thing,
यहाँ पे
1 and 3,
1 and 3. Okay.
we know that they lie in the same line as.
You are saying this would be the same line, ऐसा?
Not that.
ठीक है ना? Even then, that is still 2 points, right? 2 times it became parallel to the average velocity.
I'm saying the point connecting A and those points, how do we know that it is like parallel to tangent?
No, that is a definition. Right? What's the definition of a tangent?
It's
A line which just grazes it at one single point, right? So from this point, if I start and if I draw like this, it is grazing only at one point. Isn't that a tangent then? Isn't it? See, if you go like this, you're crossing. If you're just grazing, then you're only crossing at one point. So just grazing, it's a tangent, isn't it? Yeah. All got this question?
Sir,
So let me give you one more like this. Huh?
sir,
Sir.
which point is actually, the average velocity and the instantaneous velocity exactly? You tell me again.
What are you talking about? I didn't understand what you're asking.
I mean, the tangent is the instantaneous velocity or the
Tangent is a tangent. That is just a mathematical curve. There's nothing about that. You know what's a tangent, right?
Yes, sir.
So what is the average velocity? Average velocity is the vector from the initial point to the final point. Agreed?
Yes, sir.
In this scenario, that also became a tangent.
Yes.
And the instantaneous velocity is along the tangent.
Oh,
So there are 4 points where the average velocity and the instantaneous velocity are tangential, so they are parallel.
okay, sir.
Shreyansh, if there's an analytical you won't be able to do that. If you give me f of x, you have to draw. If you give me a curve, then yeah, mathematically there's a way to do, but it becomes quite complex. You're not a max class, so we will not do that. What about this guy? Let's try this me and tell me. Now tell me, how many times they're parallel? Zero. 9. How did you get zero, Ray? What did I tell you? From the starting point, draw lines wherever there are tangents.
Sir, like if we draw a line from A, and then how do we know that the point where it grazes only once, the point on the curve, it is the end point? I mean, the
No, I got your point. That not be the end point. Would compulsory नहीं है. Meaning, for example, देखो यहाँ पे when it grazes, this point will be the thing.
yes, that is why I did.
That's what. So that won't be the end point. That I got what you're saying. So it will be somewhere here or here, na? So still there'll be one point somewhere here. Maybe my picture is not right.
But then if that is the point where it like the tangent is, then the velocity and the average velocity will not be parallel then, right? I mean, the velocity.
Why not? Nah, see now. Suppose if I draw something like this, and suppose from here, if I draw a tangent like this is not the topmost point, right? Now, if I ask you at this point, what is the velocity direction? Won't you just draw in this direction only? Velocity is along the tangent. Tangent is simply a line which is grazing at one point. That need not be a maximum or a minimum point. Right, Ovia? Yeah. That was your confusion. So you thought maximum, minimum. No, not necessary. I didn't draw that picture that way. How many people got? People got 9, 2. Let's see. You will find, let's start from the bottom. There'll be one point here. This will be a tangent. See, that's not the lowest point. There we'll find one more point here, somewhere here, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 points here. Got this?
तो सर tangent से जितनी भी बार वो मतलब original
How many times it grazes the curve, na? That's a tangent. So that many
yeah.
times.
Okay.
There is some sort of relation between the maxima and minima.
हो सकता है. Maybe you can figure it out.
Like total number of maxima plus minima minus 1.
Anyhow, let's not do so much max. Right? Let's keep it simple. हो सकता है. Maybe I'm not saying you're wrong. But what if I give you something like this? Now can you tell me? This is your starting point. अभी बताओ. This thing still works, isn't it? Now how many maximus and how many minimas are there?
I'm confused now.
Getting it. Definition is that only. If you can draw a tangent, your answer is right. I can draw tangents. There are no maximum and minimas for this. So maybe the kind of curve I gave, na, it looks like there was a relation. But if you say something like that, then I'll give you something weird like this. And then you're gone. That's the problem. So yeah, you cannot generalize that. But got the question? This would be a simple mains level integer question. You get this kind of stuff. Maybe out of 25, they'll ask you maybe around 10 questions of this sort, where you need to think, not too much of solving and stuff. Let's see one more. We have a particle here going parallel to x-axis. So this is 0, comma d. The particle is going with speed u. This point is origin. Particle goes with constant speed u. Parallel to x-axis. Find r bar, that is okay. Find dr by dt, come mod, find d mod r by dt. The third one is a good one, right? That is something new. So in this question, I'm more keen on this guy. A time t. It is not d mod of dr by dt. It is d. You are differentiating mod r ka d by dt. Let's get this.
So is that alpha or D?
0 comma d. You don't like d, I'll take 0 comma l. Doesn't matter, some coordinate. Yeah, first two are easy, straightforward. Get me the third one. First two, there's nothing. R bar and du by dt aa jayega. That is speed u only. Find d mod r by dt. The reason I gave both is because if I give this, most people will answer for this. So I gave both just to show you both are not same. Yeah, that is okay. What is d by dt? Mod r ka d by dt. Let's see the first one.
So do we have to use inverse trigonometry, like tan inverse or something like that?
Just theta mein chhod dena and tell me theta is this karke. That will be fine. So this particle is going here. After some time t, it will reach somewhere here. This distance will be u into t. So this coordinates will be how much? Ut, comma, L. So if someone asks you to find r bar, I am indirectly asking you to find this position vector. This is your r bar. So r bar is simply ut I cap plus L j cap. Then I ask you to find dr by dt, which is actually nothing but speed only, which is u I cap. You want the magnitude of this thing. Dr by dt, which is u. Now let's try to understand the meaning of this. What is dr by dt exactly? When you say dr by dt come mod, you're finding magnitude of rate of change of position vector. Which is technically mod v bar, which is nothing but speed. Clear? But what is d mod r by dt? This is completely a different quantity. This is the rate of change of magnitude. This is not speed. This is something else. This is rate of change of magnitude. Meaning, what is the second one telling you? After some time, r bar becomes like this. After some time, r bar becomes like this. Can you see the length of the vector is increasing? So we are asking at what rate is the length of the vector increasing? Are you getting the meaning of mod r bar? What is mod r bar? Length of the vector. What is d mod r by dt? The rate of change of length of the vector. So basically this is a rate of change of. So in the first case, you differentiated a vector and got the magnitude. In the second case, you're differentiating a scalar. The rate of change of length of the vector. How do we calculate that? First thing is brute force, but then let's see what does it mean actually physically. So we know r bar is ut I cap plus lj cap. So mod r bar is root over u square t square plus l square. So when I differentiate this, this is d by dt u square t square plus l square whole power half. Chain rule everyone. Half into this will become root over u square t square plus l square into differentiate whatever is inside u square t square plus l square. This will be 2u square t by 2 root over u square t square plus l square. So we get dr by dt is nothing but u square t by root over u square t square plus l square. I can write this in a more beautiful form. So when this particle has traveled somewhere till here, this is going with speed u. If I join this line here, this is ut. If I take this angle to be theta, this is length L. This will be your hypotenuse, root over u square plus t square plus L square, and this also will be theta. You will realize this guy is nothing but u into ut by root over u square t square plus L square. This is nothing but u cos theta, where theta is the angle between the position vector and the velocity vector. So there's actually something here. So d mod r by dt is not u, but it is u cos theta. Now let's try to interpret this. What are we getting exactly? What is the mathematics part clear, everyone? This will just give the answer. It doesn't tell you what it means and all. That is there. If you go to infinity, it becomes parallel. That is there. Then theta will become tending to 0, right? Any doubts on this differentiation? Please ask me. Aditi? Shaunak, clear with this? Now let's see what it means actually. There's a much better way to do this. The idea is important. Again, we are going to encounter this in circular motion. Look at this. The particle is somewhere here, going with speed u. This is your r bar. This is your angle theta. So let's resolve the velocity into two components. So this component will be u cos theta, and this component will be u sin theta. Now tell me, what is u cos theta doing exactly there? The u cos theta, is it not stretching the vector? And the u sin theta is rotating the vector. The velocity has two components, u cos theta and u sin theta. The u cos theta is in the direction of r bar, so it is trying to stretch the vector, and u sin theta is trying to rotate the vector. That's the reason. See what happens next time. After some time, r bar becomes like this. The vector has become longer, and the vector also has rotated, isn't it? So when the particle is going in a line, you'll observe. Look at that r bar. Initially, it was here. Now it was here. Now it will be here. Now it will be here. We have a vector which is becoming bigger and bigger, and which is also rotating, isn't it? So the velocity has two components. Each one is doing its own role, getting it? The u cos theta here is responsible for increasing the length of the vector because it is along the r bar. Whereas your u sine theta is responsible for rotating the vector. Now, once you got this theoretically, now ask yourself, what is d mod r by dt then? D mod r by dt is the rate of change of length of the vector. Who is responsible for changing length of the vector? U cos theta, which is u cos theta. Isn't that the same thing we proved? So the reason we are getting u cos theta is because the velocity has two components, u cos theta and u sin theta. One guy is stretching the vector and one guy is rotating the vector. So when you say d mod r by dt, that mod r is simply the magnitude. So the rate of change of magnitude is u cos theta. Is this clear, everyone? That is the interpretation of that. So that's the reason we are getting u cos theta there. Clear? So be careful. dr by dt is not same as d mod r by dt. They are completely two different quantities. Clear? Let me show you one more like this. If a particle is going in a circle, of radius r, meaning all these things can be theoretical questions or statement questions. Okay. Now, what is dr by dt ka mod? What is d mod r by dt? What is dv by dt ka mod? What is d mod v by dt? What is integral v bar dt? What is integral mod v dt? Let's say the limits also I'll give you. Limits will be 0 to pi r by u. This will be mod v dt 0 to pi r by u. This can be like a question only. It's a good one, meaning it's all theoretical statements. T0 you're here. Can you find all these six? So we are playing with the mod. Put the mod outside, put the mod inside, the whole thing gets messed up. So particle is going in the circle of radius r. Find dr by dt ka mod, d mod r dt, dv by dt, d mod v dt, integral v dt, integral mod v dt. I can put a mod here also, since you're playing with mods. Meaning this is a pretty nice one. Most people will think this is velocity, d mod r by dt. Done? Try. I'll give another minute or two, then I'll show you. So let me ask you verbally. What is dr by dt? Dr by dt is speed, isn't it? Which is actually mod v bar, which is speed. What is speed of the particle? U. Direct thought. What is dr by dt? Rate of change of length of the vector. So let me ask you something. Is the length of the vector changing? When this guy is going in a circle, after some time you come here, did the length of the vector change? Did the length of the vector change? Where it didn't change, it is always r only, na? It's going in a circle. So this is 0. Are you getting it?
Sir, but we are talking with respect to the initial
What?
point, right?
What are you talking? What is mod r bar? It's a position vector, which is changing with time, the magnitude of the position vector. So what is the rate of change of this
Oh.
vector? It is never changing with time. Length is always constant.
Okay.
Got it? What is mod dv by dt? Acceleration. What is acceleration? U square by r. We did this thing just now. Particle goes in a circle, it has centripetal acceleration. What is d mod v by dt? This is rate of change of speed. Is the speed changing? Speed is constant. So this also will be 0. A particle is going in a circle with constant speed. Did I give that? I have to give you that. So d mod v is what? Mod v is speed. So you're asking rate of change of speed. Speed is not changing. Aditi, clear with that? Others, Tanishka? Clear? Samyak? Clear? Advai? Ovya? What about the other two? Those are good ones. Integral v bar dt ka mod going from 0 to pi r by u. What is this?
Displacement.
No, Vanshika, you're getting confused. Acceleration is change in velocity by time, not change in speed by time. Speed and velocity are not same. See, if a particle is going in a circle, here the speed is u j cap, here the speed is minus u j cap. What is the change? 2u, na? But what is the change in speed? 0. Are you getting the difference? You have to do vector subtraction. What is integral mod vdt, everyone? What is mod vdt? This is displacement. Velocity into time gives you displacement. If you say integral mod v dt, you're doing speed into time. This gives you distance. And you're asking in pi r by u. In pi r by u, the particle which is here will reach the diameter, the opposite side. So this is your displacement. So the answer for this will be 2r. In time to pi r, it will go along a circle. This is your distance, which is pi r. So this will give you pi r. Did you see? Putting the mod outside and putting the mod inside change the whole answer. So there's no need to actually integrate. You need to understand the meaning of it. Mod v is speed. Speed into time integration. So here, first you are integrating a vector and then putting a mod. Here, when you put a mod, vector became a scalar and then you're integrating. So one is a vector integration and one is a scalar integration. Are these things clear, everyone? Putting a mod inside and outside will mess up the whole, the quantity itself will change. So dv by dt and d mod v by dt are not same. They are completely two different monsters. This will be pretty good theoretical questions, meaning I can ask, put 4 of them in a question and becomes a more than one choice question. All clear with this? Completely conceptual. There is nothing too much to solve and do, but you have to just think. Anyone not clear with any 6 of this, please ask me. Siddesh, clear with this? Great. Let's do some simple thing. So we have a vehicle here. Which is going with speed v1 for time t1. Then the vehicle is going with speed v2 for time t2. These are like basic questions here. A vehicle moves in a line with speed v1 for time t1. Then speed v2 for time t2. In the second case, the vehicle v1 again, vehicle moves in a line. Vehicle moves with speed v1 for 1/3 of the distance. And with v2 for remaining 2/3. Find the average speed in both the cases. Average speed. Average speed is distance by time. So it's like you're going on your bike with some speed v1 and then suddenly you accelerate to v2. And so think of, if I were to give numbers, I'll give you like this. You're traveling with 20 kilometers per hour for 1.5 hours. Then you traveled with 50 kilometers per hour for another half an hour. Find the average speed. The second question would be like this. You're traveling with a speed 20 kilometers per hour for 5 kilometers. Then you're traveling with 60 kilometers per hour for maybe another 10 kilometers. Find the average speed. Standard questions, get them. When I say standard, think of mains and bits. Right, okay. Right, Samyak. Get this. I'll give 2 minutes for both. Right, Arya. Remember last time you were asking V1, T1, kahan se aate hain? This is the thing. Average speed is distance per time. These were easy because V1, V2 are constant now. But what if the speed is changing with the time? Then you have to use that integral formula. Integral V dt by dt and all that stuff. Right, Ishman. Yeah, most of you got the first one. Get the second one. Oh yeah, dimensions are not matching. 3 by kaisa aayega, God. 9 v1 v2 3 v1 plus x v2. Okay, I got something. I don't know the answer. I need to check. D कहाँ से आया रेशमन? D तो दिया ही नहीं मैंने. Where do you get D from? Not you. Ishman, you wrote something called D in your answer. I don't know what is D. Okay, let's see the first one. So in time t1, you will travel a distance of v1 t1. In time t2, you will travel a distance v2 t2. So average speed is distance by time. So your total distance is v1 t1 plus v2 t2 and your total time is t1 plus t2. Done. बस इतना ही करना था first one के लिए. Second one. Second one, you're saying you're traveling 1/3 of the distance. Now, how much distance? I don't know. So I'll just call it s by 3 and let the remaining distance be 2s by 3. S we don't know, so you can't give me the answer in terms of s. So for this first part of the journey, let the time t1 will be s by 3v1. For the second part of the journey, the time will be distance 2s by 3v2. The average speed is total distance by time. The total distance you have taken as s, and the total time is t1 plus t2. So this guy will be s by 3v1 plus 2s by 3v2. S will cancel off, right? The 3 will go up. You will end up with 1 by v1 plus 2 by v2. Cross multiply, you'll get 3 v1 v2 by v2 plus 2 v1. Check. So I don't know what is the distance. So let it be s and make sure you cancel the s in the ending. So you find time in terms of s and then you divide it. Have a look at this. Got this? Any doubts on this? Yeah. Any doubts on this? Anyone not clear with what I did here? Please ask. Let's make something more deadly. Not little more deadly, not very deadly. So see, same question. We have a vehicle is going with V1, then it goes V2, then it goes V3. And how does it go? Vehicle moves with V1 for half of the total time. How much time? I don't know, but in that half of the time. If the total journey took 3 hours, 1.5 hours it went with V1. Then it went with speed V2 for half of the remaining distance. So after traveling for half of the time, whatever distance is left, uska half you went with V2. And speed V3 for the remaining distance. Find the average speed. I mixed up the time and the distance together. Let's finish off. Last one for the day. So I don't know how long is the journey. Let's say if it is 4 hours ka journey, for 2 hours you went with V1. And let's say after 2 hours, 50 kilometers is left. So 25 kilometers you went with V2 and remaining 25 you went with V3. I don't know the total distance. I don't know the total time. All that I know is V1, V2, V3 and the data points. Let's get this. Answer will be bad. Try. Everyone should try. You know, one of the biggest problem you guys have, you guys don't draw pictures. Most of you have that problem. The reason why most people never improve in physics, right? Because they're very bad at pictures. You just don't draw a small picture. Okay, this is happening. This is happening. People think it's a waste of time. Once you draw pictures, maybe it's a waste of time initially, but after 6-7 months, right, your brain starts developing an ability, right, to see things in, you can see things and visualize. You are actually losing out on speed later on. And once you can't think, right, when you see a question, if you can't visualize very fast, you will slow down. You will hate physics. I'm telling you seriously. Such a simple thing as drawing a picture, right? You will not be able to learn physics properly. After 7-8 months, you will feel like, what the hell is this subject? For every equation, if you think, there is a small picture, try to put a picture. Why all that today? See, whatever I taught you today, everything I showed you with a picture. I showed you this with a picture. See, even here, when it is not necessary, I was drawing a picture. Rarely I must have taught you a question, if it is pure math, chalo, no picture, but see, I showed a picture. I could have just showed this thing, differentiation, and job is done. There is no need to explain more. But I draw a picture here also. So think about it. Your teacher is drawing a picture who cracked the exam, 360 rank, and I'm teaching physics for 16 years, and I think I need a picture. What makes you think you don't need one? Let's draw a picture. I know my diagrams are not that beautiful, but yeah, it works. So initially you're starting with V1, right? Let the total time be T. So for half the time you're traveling here, V2, so you have traveled for half the time. So this guy has taken a time T by 2. So this distance is V1 T by 2. And then let's say this thing traveled for a time V2 T2, and this thing traveled for V3 T3. And you're saying for half of the remaining distance, right? So basically V2 T2 must be equal to V3 T3, because you said both are equal, half of distance. So this is S, so this is also S. Agreed? And also T2 plus T3 must be also T by 2, because that is a remaining half of the distance. Are you getting the points there? So the remaining half is also T by 2, which you have taken as T2 T3. And the distance traveled is V2 T2 and V3 T3. And you said both are equal, because see now, speed V2 for half of the remaining distance. So whatever was remaining, uska half you went with V2 and the other half you went with V3. So V2 T2 is also equal to V3 T3. Got this? So from here I get T2 will be, I'll get a ratio here, V2 by V3 will be in the ratio of T3 by T2. And I hope everyone knows how to find the ratio here. So this is there, I can just substitute. Let me calculate that for you. So V2 will be V3 T3 by T2. Take this and I'm trying to find time now. So T2 is V3 T3 by V2. Take this and substitute here. You end up with T3 common 1 plus V3 by V2 is T by 2. You get T3 will be V2 by 2 into V2 plus V3. Similarly, you'll get T2 is also V3 T by 2 times V2 plus V3. I am trying to get everything in terms of time T. You're done actually. What is average speed? Average speed is total distance. What's the total distance? V1 T by 2 plus V2 T2 plus V3 T3 by T. Get T3 from here, substitute. Get T2 from here, substitute. Check what did I do. Did everyone get this one and this one? These are the two key points. Since the distance traveled is same, V2 T2 is V3 T3, and the time T2 plus T3 must be T by 2. And once you got this, so yeah, just let's dump it there. The average speed will be v1 t by 2 plus v2 t2. What is v2 t2? This guy, which is v3 t by 2 times v2 plus v3 plus v3 t3. T3 is this guy, which is v2 t by 2 times v2 plus v3 by overall time. Time gets cancelled everywhere. There, I eliminated all the variables. Then you'll simply get, just take out that half outside. You will get v1 plus v2 v3 by v2 plus v3 plus v2 v3 by, yeah, I got 2 v2 v3s. So that actually becomes 2 times v2 v3. Cross multiply. You will get v1 v2 plus v1 v3 plus 2 v2 v3 by 2 times v2 plus v3. This is your average speed. Lengthy. Takes time and lengthy. It's not tough, meaning it will be like, you can say moderately tough, but it's a pretty lengthy one. The main catch is figuring out these two equations. This guy and this guy. If you got these two, I think that would be the starting point. Clear with the steps? So after this, at this point, it is just calculation. There's nothing there. So the main thing is figuring out T3, T2 and putting in this equation. Any doubts on this page? Please ask me. All clear? Great. So that's a bit about average velocities and speeds and acceleration and all that stuff we did today. So next class, mostly we'll be studying with uniform accelerated motion. So A will be constant for some time. So we will study what happens when particles go horizontally, when particles go up and down. We have done something like this in foundation. We will try to do at a little higher level, right? And then after 1D gets over, then we'll go for projectile. What happens if you throw at angles and stuff? That will take time. So next week, mostly we will focus only on 1D motion, particles going in a line. Okay, with that, we'll wrap up for the day. So any doubts in today's class? Anything else you can ask me, and make sure to go through the whole notes. We have done 11 questions and there are some especially pretty good ones. If you just flip the notes pages, you will not understand anything. You need to take a paper, see the question, and then try to solve, right? So do make sure to do that. Then if you have any doubts, anything, you can stay back and ask. Or